Alright, we're going to do number 6. I don't know if I want to do number 7 yet in this video, but we'll see. Depending on if we get on a roll. I think number 6 is enough. It's A and B. So, Dad is driving the family station wagon to Grandma's house when he gets tired and pulls over on the roadside in a roadside rest stop to take a nap. Junior, who is sitting in the back seat, watches the trucks go by on the highway and notices that they make different sound when they are coming towards him than they do when they are moving away. So we got an A and B'er. Now it gets crazy, right? If a truck with a frequency of 85 hertz is traveling towards Junior with a speed of 27 meters per second, what frequency does Junior hear as the truck approaches? That's A. B, after the truck passes, what does Junior hear as the truck moves away? Okay, so step 1, highlight, circle, whatever you want to do every time you see a number. So I see that, let's see, they pull over at a rest stop to take a nap. So what does that tell me? That tells me that the frequency of the observer is 0, right? Excuse me, not the frequency. I'm sorry. Ooh. The velocity of the observer is 0. Because they're pulled over, right? We also know that the speed of sound, velocity of sound, is, I already forgot, what was it? 340 meters per second? That's right, 340 meters per second. For A, if a truck with a frequency of 85 hertz, so the actual frequency is 85 hertz, and that velocity of the object is 27 meters per second. That's the velocity of the source. Okay, cool. So we've got 1, 2, 3, 4 things. Cool, that's all we need. So step 1, write our formula. So the perceived frequency equals the actual frequency times speed of sound plus the velocity of the object over speed of sound minus velocity of the source. So this is our formula. Now let's plug stuff in. So the frequency perceived equals 85, because that's the actual frequency of the object, right? Times speed of sound plus the observer's frequent velocity. They're pulled over to the rest stop, right? Which means their velocity is 0. Over the speed of sound minus the velocity of a source. The source is, they're coming towards him. Okay, if the truck with the frequency is coming towards Junior, so 27. So 27 meters per second, right? Bam. So plug all that in. So essentially it's going to be 340 over, because this one's 0. 340 minus 27 is 320, 313 times 85 equals the frequency, the perceived frequency. Keep thinking this is an F, but it's a P, right? So that's an F, that's a P. So perceived frequency. So again, the frequency of the truck is 85, right? The truck that's moving towards them. Remember what we said. If it's moving towards them, the perceived frequency should be higher than the actual frequency. So if your number is anything less, if it's 85 or less, it is not right. If your answer is 85 or less. So once you do this, you should get 92.33 hertz. Perceived frequency. Right, so 92.33 hertz. So that's our answer A. So, answer B. Which notice that's higher than 85 because they're going towards him, right? After the truck passes, what frequency does Junior hear as the truck moves away? So, let's plug everything in. So his perceived frequency, we still don't know that, for this one, equals the actual frequency, not going to change, 85, times speed of sound doesn't change, so he's still not moving, right? So the observer's velocity is still going to be 0. Now, we know the bottom is minus the source, velocity of the source. Now the source is moving away. So in that case, let's look back at this other page here. Velocity of the source is negative if the source moves away from the observer. So if it's moving away, you're doing minus, because you always do minus the original formula, a negative 27, right? So it doesn't mean we keep the sign. It means we keep our same original formula, but this number is now a negative. Which means, when we rewrite this, 85 times, I'm just going to put it in parentheses, 340, because that's on top, 340 plus 0, over, now it's 340, if it was minus a negative 27, it's pretty much 340 plus 27. So it's 367. Hopefully everybody gets that. You add it because it's minusing a negative. And it's negative because it's moving away, like we just saw on that previous page, right? So, final answer, again, it's moving away. So if this is the observer, and this is the source, and the source is going this way, the perceived frequency will be less than the actual frequency because it's moving away, right? With that being said, you should have gotten 78.75 hertz, which is, again, less than the actual frequency. Alright, so that sums it up. I might do one more. I'll do number 7, and then that'll be it. I'm going to do that in another video, though.